Welcome to AI driven perception, learning and mapping for drones. The lecture covers on foundation in convolution neural network. We'll talk more about building blocks in convolution neural network. The previous lecture we introduced why vision is difficult in fully connected network, right? What is the visual structure? What is the need of local feature, spatial invariance? What are the viewpoint challenges and other aspects influence, right? So in this lecture, we will build basic blocks, understand how one process the visual informations, and then we'll start looking at complex architectures for solving real problems in aerial perception, right? In this lecture covers classical digit recognition problem, handwritten digit recognition problem. Moment I say handwritten digits, you need to understand the style differs. If I ask you to write in a whiteboard, somebody can write very big, somebody can write very small, and you can write it in different orientation and different styles, right? When you have these variations, how we are going to recognize the digits, that's a basic building block through which we'll try to understand the functions of convolution neural network. Then we talk about what is the basic operation, the convolution operation, how does it work, how it is helping to extract a local feature. Then we talk about another important operation called pooling, right? Then we'll introduce activation functions specific to convolution neural networks. Then we present a simple one-layer CNN for digit recognition problems. Then we introduce a paradigm shift in CNN, right? How convolution neural networks introduce a shift in paradigm when we are trying to process. Earlier people, what they used to do, when the image is given, there will be an expert who will extract features. He will extract features based on a specific filters and say these features are what we need to use to recognize the face. And this is what we need to recognize the apple, right? Apple, when we say, we talk about color, we talk about shape, we talk about texture, right? Color I can understand to some extent, right? Red apple colors are red, as you can see a green apple. To some extent the combination of a pink might come into picture. But there is nothing called apple color, right? What combination of these colors constitute an apple is what we need, right? When we talk about shape, we know circle, 2D means circle, right? Or a sphere, ellipse, triangle I can understand, square and rectangle. If I talk about in 3D, you can represent that. What's the apple shape is? Is it sphere? Is it cylinder? What is that shape is? Now think about it. If I cut the apple into pieces, there is no color, and peel the skin, still you can identify it as an apple. The fundamental feature which we talked about, the color, right, and the shape is gone, but still we can identify whether it's a cut apple or not, right? So how human represent that information is very important, right? Now I said I need a simple example so that I can articulate what is this convolution neural network, right, is all about, and construct the building blocks. Then we can appreciate complex functions of this CNN to identify objects, various objects, and how it can recognize very efficiently and all this, right? Let's look at handwritten digit recognition problem. Moment I say digit, it can go from 0 to 9, right? So this is what we are talking of, the basic digits that we are interested in, right? 0 to 9. I ask someone to write 0, the way they write, this pressure that they apply will differ, right? That's a bigger problem. For example, if I ask someone to write number 4, you see what kind of variations that I can get. some numbers look similar to 7. If you look at this number 4 and number 7 and number 9, there is a similarity, some kind of similarity, right? So the variations in these digits and the location in which he is writing. Let's say I just gave the space. The space that I am given is the red space where you have to write. Somebody can write number 4 here. Somebody can write number 4 like this. Somebody can even write number 4 in this direction also. The orientation can change. The scale can change. The style can change. The pressure that he applies to write the number can change. There are so many variability that you could have, right? What is my objective? I want, and I am going to take this red region as an image, and I want to identify what's a number written in that particular image, right? So develop a convolution neural network to classify the image to a specific number. I asked him to write only one number, not multiple number. Remember that. Now first let's solve the one number, then we'll come to the problem of how many numbers are written in an image and how to do that subsequently, right? In a given region, you are asked to write number. You can write however you want, right? That data set is called MNIST data set, Modified National Institute of Standards and Technology. That's the abbreviation, and they collected this data set. There are about 70,000 images are there. Each image is 28 cross 28. What's the challenge here? Human writing style vary significantly. Digit can be shifted, rotated, stretched. There could be similarity between number 4, number 7, number 9. Sometimes people even write number 1 like this, right? If I add extra here, that becomes number 4. If I just write only this portion, it becomes number 9. And if you don't put anything on the bottom, it could be number 7, right? There are a lot of similarity between them in the style. That makes the problem much more interesting to solve, right? If you are trying to solve this particular problem, what we need? We need a local curves to be identified, right? What we are looking at is the edges and curves to be identified. We need to identify a horizontal stroke. We need to identify the vertical stroke, right? And we need to identify whether any loops are there. If I have to recognize a number, what is the basic thing I have? Is there a horizontal stroke? Is there a vertical stroke, right? Or is a slanted stroke? I need to know. I need to identify whether there is a curve, there is any loop, right? If you look at number 8, it has 2 loops, two closed loops. So these are the things that I wanted to extract, and that becomes my local feature. If I put combination of this local feature, I can create a multiple templates which includes different variations of same digits, right? We talked about the spatial network, so I just thought mathematically let's define the process, right? This is an image. This image I said it's going to be 28 cross 28 for a digit recognition problem, which means 28 rows and 28 columns are there, right? I am going to extract a local feature, that's my F, right? Local feature from the region which is marked in red color, right? So I need something there. The size of the region could be m comma n, right? Where should I start? How do I slide? If I want to represent, if I say the convolution operation between I and f, which is nothing but summation m, summation n, I, capital I is the image, I comma I plus m comma j plus n multiplied by f of m comma n. That's what we meant, and which extract the local feature which I can represent in the higher dimensional space. Next, hidden layer, right? I is the image patch, that what we are talking of. F is the filter that I am trying to process to extract a local feature which I am going to use it in the subsequent phase. If I slide it further, I will have one more local features. I process this till I get a feature map or activation map. You will see this in the next slides, right, and you will be able to appreciate. For example, right, I am going to define my image is going to be 5 cross 5. I am going to take a filter which is 3 cross 3. Okay. For ease, I am going to take image as only ones and zeros, so my computation become much faster, right. So what I need to do? I need to pick a patch. The patch size should be equal to the filter size, right. So there is a 3 cross 3 patch which is highlighted with the blue color. I am going to multiply this. I am going to take a convolution of that image patch with the filter. This is a I, this is a filter, right, and this is my patch. So if I am trying to do, what is that I am trying to do? How I get this 3? The first 1 into 1 plus 1 into 0 plus 0 into 1, that is a first row. Second row, if you see, 0 into 0 plus 1 into 1 plus 1 into 0, that is my second row. The third row is 1 into 1 plus 1 into 0 plus 0 into 1, right, that is how, right. So every pixel in the patch of I multiplied by the corresponding pixel in the filter, summation, right, that is what we represent, summation m, summation n, I of I plus m comma j plus n into f of I comma j, right. So that is what we are trying to do. This is for the first patch. Now if I slide to the second patch, what will happen? I have to do the same operation. Then if I slide further every patch and all the way, finally I got a local feature extracted from there. This is my activation map. But if you notice, I started with 5 cross 5. My filter size is 3 cross 3. My activation map size is 3 cross 3. A 5 cross 5 image with the filter of 3 cross 3 resulted in an activation map of 3 cross 3. Okay. What happened to the activation map size? The activation map size is smaller when compared to the image, right. Now we are going to look at very interesting operator called pooling operator, right. It is trying to compress the feature map while keeping the most important information, right. Intuition is you identify the presence of local feature. You may have a lot of information, I just want only the local feature, right, if I have to do it. For example, if I take a 3 cross 3 feature map, right, I want to do pooling, max pooling, right. Max pooling means you take a small patch, find out the maximum number, that is the information I wanted to retain, rest I do not want to do it. So you look at this patch, the maximum is 5, I kept it. You can do average pooling. You take the patch, take an average of it. For example, 4 plus 3 is 7, 7 plus 5 is 12, 12 plus 4 is 16, there are 4, average is 4, that is what it is. I can have average of information, I can have max information, that is what we are talking about. The max pooling stores the strongest information, the average pooling talks about overall presence of local feature. So you have to understand what is the purpose of pooling. Pooling reduces the dimension, right. Here 3 cross 3, you will get a 2 cross 2. You can reduce the dimension. It is robust against the translation, whatever the change is happening. It keeps the presence of local feature, retain the local information or overall presence information, right. So these are the two operators that we are talking of, right. I can process the whole thing and get the local features. Remember, pooling operations also lose spatial precision. The 3 cross 3 is my activation map. If I do the pooling, I'll be able to reduce it to 2 cross 2. If you do the pooling with the 3 cross 3 patch, it will reduce to single feature, right? So that's important. Spatial precision is lost, not the information. Spatial precision will be lost. Okay, so we saw two basic operations. One is a convolution, the other one is a pooling operation. Very important, like feed-forward neural networks, shallow neural networks like MLP or radial basis function, we need to have an activation function, right? Why do we need activation function? We discussed in the first module itself, right? So we want these activation functions to project this information in a nonlinear space, and then using that information I wanted to learn the complex relationship, right? What are the activation functions used in convolutional neural network? I have rectified linear unit, or what we call ReLU. I have exponential linear unit, soft plus, scaled exponential, leaky rectifier linear unit, max out. I can use hyperbolic tangent too, right? Or I can use a hard sigmoidal function. Now, if I look at rectified linear unit, mathematically if I have to represent max of 0, x. Now think about it in image, and we are talking about RGB value. Can any of the pixel value be negative? Right? So I don't want negative. So I can just put anything less than 0 is 0. Right? Any other value I can just retain as it is. Right? So 0, x, max of 0, x. What are the important properties of this ReLU? It's biologically plausible. Right? Some neurons do behave something similar, so biological relationship I can establish. It does not saturate, because it's a linear, it does not saturate, it can keep going, right? It converges better than sigmoidal and computationally very efficient. I am not going to prove all these aspects. If you are interested, you can just read through the textbook which talk about how we are saying it is converged better than sigmoidal and all that. What are the challenges here? It is not centered. If you look at the behavior, it is not centered, right? Remember the input data, it need not be centered, right? It can distribute. So that causes sensitivity to the data distribution. Gradient is not defined for a negative input, right? Anything less than 0 is 0. There is no activation on the negative space. If it's -1 also 0, -10 also 0, -100 also 0, right? It doesn't have any variation in negative space. Then people thought, why don't we just do leaky ReLU? Instead of 0, it is some scalar times x, alpha times x. Now we solve the problem of response at the negative space, and there is some gradient exists also, right, in the negative space. But still we have not solved the problem of centering, right? It is not centered, right? Not zero centered output. That is going to be sensitive to data distribution, right? Rest of the properties remain same, like biological plausibility. It does not saturate. It converges better than sigmoidal. It computationally efficient, right? But one can parameterize this function. All these properties exist. If we solve one problem, but one other problem still remains same. Then I can go to exponential linear unit. In positive it is linear, in negative it is not. Alpha times x is exponentially decaying function. For example, mathematically if I have to represent y is equal to x, if it is x is greater than 0, otherwise alpha times e power x minus 1. right? So I can have this. Compared to sigma, it will be better, right? Close to zero mean output, it's possible. Negative regions does saturate here, remember that. Some robustness performance against noise will be there, but computational cost increased. I am compromising here, right? Earlier there is no e power x, now there is a e power x. So my cost of computation in y as well as gradient is going to increase. I can go max out neuron. Mathematically, what does it mean? I can have different linear projections. I can find out whichever the linear projection gives the maximum, right? W is my weight, W into x plus b. So basically I am just looking at different lines and projecting that particular x into that line. Whichever line gives a maximum, I can take that out. The shape depends on the learning process, the activation function shape, right, depends on the learning process, the w's and bias b, that what we are trying to learn. It beautifully approximate any nonlinear function piecewise, right? You can approximate convex functions too, but it's maybe suitable for audio data, right? If your input data is audio, it is more suitable, but not for visual structures. At the cost of what? Because I have a multiple linear projections, my computational cost is going to increase, and these parameters need to be learned. The again convergence to the optimal projection going to affect, right? Local minima comes into picture, all the problems of learning comes into picture. It increases the dimensional space of the data, right? Dimensional space of the weights that we wanted to learn. In turn, which will affect convergence of the network, right? So I can use a soft plus. Mathematically, y is equal to log of 1 plus e power x. I can do that. It gives a smooth approximation of the ReLU. It is continuous and it is differentiable, no zero gradient, no better numerical stability, but computational complexity. Convergence also will get affected. Okay. Now, I introduce the basic convolution process, right? I talked about what is convolution operation means. We saw given a 5 cross 5 image and a filter of 3 cross 3, how you can get the activation map using convolution operation. We saw one more operation called pooling. The pooling operation, what it does, it just look at the region of the pixel. It can either do max pooling to extract the maximum information, local feature, or average information present in the region to retain it, right? Both the operation was reducing the dimensions, right? Now, what was my objective? Objective to teach a one dimensional or one layer CNN to extract the hierarchical features to identify the digit present in an image, right? Let us say the image, input image contains some digit. It looks like 3 here, right? I may have to put some convolution layer which process this image, and it maybe keep reducing the activation map, right? Finally, I may get some activation maps, and then from the activation map I could extract the maximum information. I could have a pooling layer which extract the maximum information, and that becomes my feature space, right? I could pass on to something else to find out the class. Here with the maximum feature space, I am just saying that okay, here the digit look like a 3 or digit look like what, right? So for example, I have only 4 digits 0, 1, 2, 3, right? In this case, what will happen? The last vector should be maximum when compared to the other. So if I get an output like 2.1, 0.6, 4.5 and 8.4, then what does it mean? What the way the person has written a digit, it looks with the highest probability towards 3, and it's something similar to 2 as well as 0. That's what it means. But doesn't look like a 1 because 1 requires slanting in a stroke, no curve, right? So I can identify that. So how are you going to do it? But I have to learn the filters, right? Convolution filters. How am I going to learn the filter? I may have to put some activation here. I'm just not doing anything just to get the basic structure for you to understand, right? So I use a cross entropy. Remember we talked about cross entropy in the loss function lecture, right? I use a cross entropy and I identify the error. That's my loss function. I can compute the gradient and update the filter by passing the gradient through it, right? Now, if I had to do the digit recognition in a generic architecture, there is an input image, right? I have mentioned as a 32 cross 32. I think it should be 28 cross 28. I'm going to extract the feature map, right? It's basically sampling the input, reducing the feature space, and from there I'm going to reduce it further, subsample it, and then finally I'm going to construct the feature vector and passing the feature vector to a fully connected layer, right? And asking the fully connected layer to identify whether the given input image is contain the digit 0 or 9. Now what happened here, I have extracted the higher level abstract feature automatically and used that abstracted features to identify the digit, right? Earlier shallow neural network required the feature space to be given. Somebody have to design the feature, extract the feature, right? If the feature is there, I can use it and learn it accurately. If the feature is not given, then I have to extract it automatically from a visual image. So if you look at CNN, it learns the feature and also helps you to identify whether this particular feature is in what category, right? So we need to learn the filter weights, we need to learn the weights of the fully connected network by minimizing the cross entropy loss function, right? That's my loss function. So I can compute the gradient and update all the layers, right? Now let's look at how does a paradigm is shifting before CNN came into picture, after CNN. Before CNN, if you look at, we always have handcrafted features. An image is given, somebody will identify. What is the local feature here talking of? Is there a stroke? Is there a curve? Is there a loop? Right? I have to extract this. People use filters, descriptor like shift and org and extract them and pass it on. You need a domain expertise. What kind of filter should I do? What kind of local feature that filter will extract, right? You need that domain expertise. The performance is limited because it's spatial invariance and everything. Somewhere, where is the digit? He has to identify first. He has to look at the orientation and apply, right? Usually once the features are extracted, shallow neural networks were used and then they learn the relationship and to identify. It's a process is slow because you need someone and he need to extract those features, and once the features are extracted, you need to give it, right? Computationally expensive, it's a contradictory statement to discuss, right? What I meant computationally expensive is feature extraction process is independent and the classification process is independent. You extract a feature, build a model, and then you see the performance. If the performance is not good, we need to know whether the performance is not good is because of the neural network convergence problem or the feature is not describing the data completely or not, right? Now, if the feature is not describing, what is the next feature that I should add so that the performance improves? See, that process is what I meant computationally expensive. Okay. If you look at CNN, I am extracting feature automatically. I am learning the feature, learning to identify what filter I should do so that it gives me the feature which is good enough for me to identify the digits accurately. The entire process is data driven. It's more like an end-to-end learning. I extract the feature learning as well as the classification simultaneously. Its performance is superior when compared to for a given, because the problem there is, how do I handcraft my features? Does the handcrafted feature represent the entire distribution or not? That's a bigger problem, right? If you look at it, architecture is big, right? I need a GPU system to train the network and all that, right? Because architecture is big, more parameters. So it takes time to learn. That factor is there, right? I may need a better compute facility so that I can extract the features as well as identify the category simultaneously. That's a paradigm shift. The thing is, it's not like a fully connected networks. The weights are shared. The filter is a filter. It's the same filter applied across all the patches. You may have a different filter, again run through all the patches, right? Same filter extract a local feature without translational bias. There is a local connectivity. Neurons are connected to smaller patch to retain the spatial awareness aspect of it. The features are represented in hierarchical fashion. We talked about it, right? How the cognitron comes into picture, where V1 cells and the S cell and C cells, how they combine together helps you to extract the information in hierarchical fashion, right? The layer by layer, simple and complex abstract features are extracted in this network. So end to end, the feature learning and the classification happens simultaneously. That's a shift in paradigm we are talking of, right? Why it matters. I need a better performance. That's a very important thing, right? Of course, accuracy is very, very important for a complex visual task. What I meant is, there is an image. There could be many cars. Can you identify the car is Hyundai or Honda or BMW or Audi? You have to identify, right, which brand it belongs to. The task becomes very complex. It may be hidden, right, partially occluded. Scale could vary. You may have a board which talks about a bigger version, right? It's bigger than the advertisement board will be there, which is much bigger than the actual car size possible, right? So scale change, occlusion comes, lighting variation, viewpoint variation. With all those variation, the interclass variability can come into picture. With all that, can I get a superior performance? That's an important requirement. I don't want to depend on human expert to extract the features which is more relevant or best representing the data, right? Can I learn it just by looking at the image and get my feature space as well as decision space learned accurately, right? I want that kind of an end-to-end training. Scalability should be there. It should be applicable for a wide variety of visual tasks, right? If all this possible, then yes. So if you look at the current state of the art in CNN, right, I am not bringing in, I'm just based on the review article published in 2017, almost 9 years old, right? Because we are talking about convolutional neural network. I am just stopping it there to give an understanding. A typical problem of what we call topology versus network, right? To see how its accuracies are improving, right? You see, when the architecture complexity increases, the performance also start increasing, right? When the complexity of architecture increases, the size of the architecture, number of parameters leads to the computational cost, right? If I look at computational cost, when the accuracy increases, the computational cost also increases. Right? You have to have an idea. If the number of parameters is higher, right, and you need more data to it, if it's more data, more time it takes to learn, but better its performance is. Right? That's the thing you need to understand, model size versus accuracy. Then again question comes, we are talking about drone. If the size is so big, can I put it in edge level? So that's where the model size matters a lot. Without compromising size of the model, say when I say compromising, without compromising the accuracy of the model, can I reduce the size? That's a question, right? So that it becomes edge deployable, and real time you can process the data. Either you reduce the size or increase the computational power. If you increase the computational power, then the endurance of the drone will come down, because the battery has to supply power both for processing, right? So this is a factor you need to consider when you are trying to optimize your performance of the whole system. In summary, we talked about a classical digit recognition problem, and we saw what are the challenges in the digit recognition problem. I have introduced basic convolution operations, right? Convolution and pooling operation, different pooling operations, what exactly do. And we talked about different activation functions one can use in CNN, and we build a single layer CNN for digit recognition problem. Maybe in one of the tutorial, we will just take you through how to load this data, how to construct the architecture, and how to use the gradient learning process to get the best parameters out of it. We will do the demonstration in one of the tutorial. Okay. We talked about the paradigm shift, how earlier people used to use handcrafted feature extractions and shallow neural network for classification. Now there is a shift. We look at end-to-end learning. We learn the feature which helps us to classify simultaneously. In the next lecture, we talk about the more details. Suppose I don't want to lose the spatial precisions. What should I do? How do I do? Right? My image is not just RGB, my image is not just one dimensional, it becomes multi-dimensional. What should I do? How do I construct my architecture? And how do I process the complex visual task to extract or identify the information will help me to understand the scene better. Because that's very important for decision making process of the drone, right? So we will talk about the different functions of convolution neural network helps us to extracting the informations in a hierarchical fashion. Thank you.